We can use the double angle formula of sine 2a, cos 2a, and tan 2a, or theta, to help us simplify expressions. These involve the trig functions of double angles, and they're derived from the addition formulas. There's a link if you want to get the proofs, although you do not need to memorize the proofs for this course. So the first question we're going to look at, we're going to simplify the expression 2 sine pi over 8 cos pi over 8. Now, we're going to be using sine 2 theta for this one. Because this is derived from the double angle formula for sine. So if we look at sine 2 theta, we're going to have sine 2 pi over 8, which is equal to sine of pi over 4. And then sine of pi over 4 is 1 over root 2. So we've simplified. We have another one here, 2 cos squared pi over 6 minus 1. So this is the double angle formula for cosine. So we'll have cos 2 pi over 6, which equals cos of 2 pi over 6, which is cosine of pi over 3. Cosine of pi over 3 is 1 over 2. And finally, let's look at one that involves tangent. So we have 2 tan pi over 6 over 1 minus tan squared pi over 6. So we're going to have tan of 2 pi over 6, which is equal to tan of pi over 3. And tan of pi over 3 is equal to root 3 over 1, or just root 3. So we use the special triangles to evaluate tan pi over 3. If you know one of the primary trig ratios for any angle, then you can determine the other two. And you can then determine the primary trig ratios for this angle doubled. Okay, so for this next one, we're given cosine of A is equal to negative 2 over 3, and then we're asked to determine cos of 2A and sine of 2A. So there are 3 double angle formulas for cosine, and since the value of cosine theta is given, we're going to choose the formula that is in terms of cosine. So we will have 2 cos squared theta minus 1. So that is 2 cos squared minus 1, which gives us 2 times 4 over 9 minus 1, which is equivalent to negative 1 over 9. Now, if we look at which quads this can be in, so the value that we're given, cosine is negative. So that means, according to the cast rule, it can be in either quad 2 or quad 3. Now if it's in quad 2, we know that for cosine, we have the adjacent over the hypotenuse. So our adjacent would be -2, hypotenuse is 3. So to find the opposite side, we would have 3 squared minus -2 squared equals y squared. So then we have 9 plus 4 equals y squared. Sorry, this is a minus. And then we have 5 equals y squared. So this can be plus or minus. So y is equal to √5. So therefore, if we look in the next quadrant, what would we have? So we would have -2, and then they're the same value, so we would have -2 again, 3, and then this time it'd be -√5, and up here it'd be positive √5. So if it's in quad 2, we have positive √5. If it's in quad 3, we have -√5. So therefore, when we're looking at sine 2 theta, sine 2 theta equals 2 sine theta cos theta. So it'd be 2 and then sine theta and then cos theta. So that gives us 4√5 over 9. So we found cos of 2a is -1 over 9. And we found sine of 2a, which is 4√5 over 9. Now for this one, we're given cosine of x is equal to 6 over 10. And the interval is between 0 and 2 pi. We're going to determine all 3 double angles. So we're going to determine cos 2x, sine 2x, and tan of 2x. So the first thing we're going to do here, we have cosine. So this is the adjacent and the hypotenuse. We do not know the opposite side, so how would we find that? If we're looking for the opposite, so y squared equals r squared minus x squared. So y equals 100 minus 36. Y squared equals 64. So y is equal to 8. So when we draw our sketch here, well, where is cosine positive? So we're going to have in the first quad and in the last quad. So in the first quad, then we'll have 10, 8, and 6, whereas in the last quad, we'll have 10, -8, and 6. So sine of x equals 8 over 10, or sine of x equals -8 over 10. And then tan of x equals 8 over 6, or tan of x equals negative 8 over 6. So we're going to have two answers. So first let's find sine 2x, which is 2 sine x cos x. So you have 2, 8 over 10, 6 over 10. That gives us 96 over 100. If we reduce, we get 24 over 25. So that's the first answer. The second answer, we would use negative 8 over 10 because we know there's two possible answers, quad 1 and quad 4. So we get negative 24 over 25. So we have our two possible answers for sine. Now we're going to do cosine. So cos 2x equals cos squared x minus sine squared x. We can use these because we have both cos and sine. So we have 6 over 10 squared minus 8 over 10 squared. So we got negative 12 over 100, which is negative 3 over 25. And then for the last one, we'll have two answers as well. For this one, we don't have to worry about the two answers. We'll get the same value. So for tan 2x, first answer, we get 2 negative 8 over 6 over 1 minus negative 8 over 6 squared. That gives us negative 16 over 6 over 1 minus 64 over 36. So we end up with negative 96 over negative 28. When we reduce that, we get 24 over 7. Whereas for the second one, we're using positive. So we get 16 over 6, 1 minus 64 over 36. So this time we end up with positive 96 over negative 28, which is negative 24 over 7. So notice we have two different answers for this one. Same values, but one is negative, one is positive. So when we're working with the double angle formula, very similar to the last lesson, you're using the formula to help you simplify expressions and to determine the values. If you are unsure of one of the sides, whether it be the terminal arm, the opposite over the adjacent, you are going to solve for those values. Once you solve for those values, then you're good to go.